So in your conclusion, you want to address your question. You also want to support your claim with evidence, and you want to explain your reasoning. So your claim is your hypothesis. So let's take a look at what this conclusion looks like. This is not perfect by any means, but this is this is the direction I'd like to see you start to move. So as we compared the volume change of the experimental group, it was apparent that the water level went up inside the test tube. That's evidence. The change occurred over 3 days, as the line graph shows, though all three trials had slightly different values. An overall pattern was clear, as was the final volume. That is more evidence based on that results and analysis section that we just looked at. Now, there's a lot of implied information for anybody who needs to go back and read the background, which I didn't write in detail, but we went over in class. That background information where we talked about the amount of what gas does, that whole section of the concept map that we went through as far as the background is concerned. So all that background information supports the meaning of these two pieces of evidence. So it says, we predicted in our hypothesis that the final volume of gas left in the test tube after all the oxygen was reacted would be less than the beginning volume, and that it would be equal to the percent oxygen composition of the atmosphere. Now this was our hypothesis. These two pieces of evidence support this hypothesis. At the end of the 3 days, we concluded that the atmosphere is made up of about 21% oxygen, 79% other gases. So I think that's clear, and you saw the pie graph earlier in the data analysis section. Could you spend more time developing these? You could, but if you think of a lab report as put together into different parts, you'd see that the background already discussed a lot of this information. You already looked at a lot of the control groups and the experimental groups. You did the data analysis already, so all that's done. And so here's your statement. There it is. And so here we continue by saying, there's one troubling question that is evident, and that is that the graph of the volume change did not flatten out. We expected the change in volume to be zero when the oxygen gas was used up. We believe if we waited another day, the data would show this zero slope. So here, again, you saw that there was a problem with the data. The data in the data analysis you saw that there was no end. It didn't actually flatten out. The line didn't actually flatten out, and that's a problem. If it didn't flatten out, where was the oxygen coming from? Well, there was still a little bit of oxygen left, but given another day, one would suppose, as you see here, that there would be no oxygen left, and that it would be a flat line, a flat horizontal line. So that would be predicted if we did another day, another experiment, did it again. This time we let it go for 4 or 5 days. We would expect that would actually flatten out, and that would also support this 21%, 79% value. So that would lead us to another experiment the following day, which we don't have time to do, but you can see how science is never ending. Each conclusion leads to another set of questions or other experiments that need to resolve any troubles or conflicts or issues that come up from your results. The evidence supports 21% oxygen as a summary. Your conclusion should answer the question, use the background information for support, use the data analysis and address any flaws in the data analysis or any flaws in the design. And if there is a flaw in the design, or how you did it, then your conclusion should discuss that. You should say, well, our water level didn't go up, and we think it was because the test tube was inverted, or we think that we measured incorrectly, or something, and then say what you would do to correct it in the next experiment if you had time to do it again. Which again, in this class, we won't have time to redo experiment time and time again, but that's what you would do in the laboratory. You would do it over and over and over again until you got it right. Okay, let's go on.